and check them out. If I use a height of 5, that means I would do 5 minus 17 for this base of the triangle, and that comes to a negative 12, and I can't have a negative 12 for a length. So I have to disregard this solution. Even though it's positive, it makes one of my lengths negative, so I can't use it. Now my other solution is h equals 45, and I can have 45 for a height, and 45 minus 17 will be a positive number for the base, so it's also not going to be a problem. And it comes to 28. So 28 is a perfectly reasonable number for a base, and then 8 more than 45, which will be 53. That'll be fine for my hypotenuse. So my answer then is 45 feet. Okay. Here's our last problem. We have Joyce dropping a quarter from a building that's 1,296 feet high. The path of the quarter is modeled by this equation. Negative 16t squared plus 1,296. This 1,296 is in our equation, so we don't need to do anything else with it. And we want to know, when will the quarter be 896 feet from the ground? So we should think about this again, and I have two variables. One is h of t, and the other is just t. Now the h of t, if you remember from the problem we just did, that's going to be your height. And the t by itself is going to be the time. Now for this first problem, when will the quarter be 896 feet from the ground? The 896 feet, that's our height. So I need to use that instead of my height here. And here also. So I'll put 896 feet in for the height, and it'll be negative 16t squared plus 1,296. Now this is going to be my equation, and I'll want to set it equal to 0, so I'll subtract the 896 from both sides, and it's going to be 0 equals negative 16t squared, and that'll be a plus 400. Now I do want to try to find a greatest common factor, and I'll try 16, so 400 divided by 16, and that comes out to 25. So I can use negative 16 as my greatest common factor, and I'll have left t squared minus 25. And then I want to factor inside the parentheses here, and that is a difference of squares, so it'll be 0 equals negative 16 times the quantity t plus 5. I have to take what times itself equals 25, and t minus 5. Then I can set each of those factors equal to 0. T plus 5 equals 0, and t minus 5 equals 0. Because there's no variable here, this one is just garbage and I can't do anything with it. This one I can solve for t, and it'll be a negative 5. And when will the quarter be 896 feet from the ground? Can I say in negative 5 seconds? No, so this one has to be disregarded also. And my last one comes out to a positive 5, and that is my good answer, so 5 seconds. All right, then my last question, when will the quarter hit the ground? This was 896 feet from the ground, so I knew how many feet to put in for my height. This one is, when will it hit the ground? I have to remember that the ground is 0 feet high, and so then I'll use this for my height. And here where I have h of t as my height, this time I'm using 0 for the height. So I'll put in 0 instead of the h of t, and it's negative 16t squared plus 1,296. And then I'm checking to see if I can divide that by 16, and it's 81. So I can factor out that negative 16, and I have t squared minus 81. Now I want to factor the part in the parentheses, so I have negative 16, and I see that that's a difference of squares again, so I have t plus, what's the square root of 81? it's a 9, and t minus that same 9. Now I can set each of my factors to 0. I'm pretty sure this one's going to be useless, and the t plus 9 equals 0 will result in a t equals negative 9, which again I can't use, and the t minus 9 equals 0 gives me a solution I can finally use, and my answer is 9 seconds.